Hello out there to you. In this problem, we're going to find the marginal rate of substitution for these two functions. So the marginal rate of substitution is the negative marginal utility of good x over marginal utility of good y. If you have a problem where they're not x and y, just whatever, one product over the other product. Okay. Now the marginal utility is the partial derivative with respect to whatever that variable is. So for each of these, so we're just going to do a bit of calculus here. I'll do this one over here and this one over here. So marginal utility of good x is this part. This will become a constant. This would be like 3x to the first power. So then we multiply that by 1, and then we subtract 1 from that exponent there. So we end up with -3 is the marginal utility of the good x. And then for good y, there's no good y in this part. So we just take the marginal utility with respect to y. And so each unit of y adds to total utility by 1. So that's going to be 1. But it's really like this is 1, this 1 times 1, then this becomes y to the 0, and we just have 1. So this one is -3. We can simplify that. Okay. So now this other one, we want the marginal utility of good x over the marginal utility of good y. Okay, so marginal utility of good x is, this is a 2, so this becomes 2, and this is a negative. So it'd be -2 x times y squared. We have to leave that on there because it's not adding to it, it's part of that piece of the function. Next, we're going to do marginal utility with respect to y. So this would be 2 multiplied by the 1. So that would be x squared and then y. Okay, and now we can simplify this. So 2 over 2 becomes -1. So I don't really need to write that. I don't need to write -1, but it's assumed that it's there. Okay, now this x can go down here, and that's like when it goes down to the denominator, it's x minus 1. So then it would be x minus 1 and x2, combine those, and I got just x1. I don't need to write that x1. It's assumed that it's there. And then when I send this guy up here, this is x to the -1 up there. So I'm going to combine that. I'm sorry, not x, it's y. It's y to the -1 right here. When this exponent goes up here, not the exponent, when this value, this y, goes up here, it's y to the -1. So I combine those, and I've got y -1 plus 2 equals, so the equals y to the 1. So it's like y1 over x1, and this is just like saying -y over -x. And so that's how to calculate marginal rate of substitution. It's the ratio of these two marginal utility functions.